Hi, everybody. Hey, I just want to say I know that this is not easy, and I just want to thank so many of you who are doing the very best that you can with this, and those of you who reach out to me and send me messages and ask questions and meet up in Google Meets to try to clarify things. I think it has helped, and I just want to encourage any of you who are feeling confused. Sometimes just asking a quick question and getting something clarified really helps. So I encourage you to do that if you're confused. The two questions we're going to look at on the homework is Part A and Part D. Okay, both of these problems were problems that we're asking you to graph in degrees. Okay, it's looking like the majority of you have definitely caught on that it was certainly stressed in the video that it is absolutely crucial that you are labeling the 5 critical values along the x-axis. Okay, those are all going to change with Monday's lesson. It's going to get more difficult on Monday. But right now, if we're in degrees, it's 0, 91, 82, 73, 60. Okay. Most of you are also labeling the y-axis. That needs to be labeled as well, okay? So here we are going to identify the midline as being the 2, okay? So I'm going to put that on the line here for midline. I'm going to go ahead and label. Here's what I'm talking about labeling. You're going to put that dashed dotted midline across from 2. Okay, the amplitude is always a number that's positive. So even though you are seeing a negative 2 in front of cosine, you want to write down that the amplitude is technically a positive 2, and the fact that it was negative means this cosine wave is going to be flipped. Okay, so a couple of things you want to kind of commit to memory is the parent function for the cosine wave is a valley, and the parent function for a sine wave is a small hill followed by a small valley. Okay. All right. So the next step, I'm going to just set up a little bit on the y-axis because I'm going to start by placing some points along my midline depending on the wave I'm graphing. But I know that once I get those points on the midline, I'm then going to need to do some stretching above the midline as well as some stretching below the midline, and how far I stretch is dictated by what the amplitude is. So if my amplitude is 2, then I need to be able to go up 2 more from the midline, as well as make sure that I can go down 2 more from the midline. That would land me right on the x-axis. Okay, so now I think we're ready to actually put points on the midline. Okay, when you start with your points, you always start with the midline. Okay, that's that dotted horizontal line. This is a cosine wave. Cosine waves cross that dotted midline at the 1/4 and 3/4 the way, excuse me, through the period. So that would be in this case at the 90 and 270 degree mark. Okay. Now remember, we said this wave is flipped. So typically at the beginning of a cosine wave, you start up. And then in the middle it dips down, and then at the end you're back up again. But in this case, because I'm flipped, at the beginning of the wave, I'm going to start down, and in the middle, I'm going to go up, and at the end, I'm going to go back down. Now, where are you going down from? You're going up and you're going down from the midline. So it's like you want to have your pencil kind of floating at the beginning of your period, which is at 0 degrees. Have it floating right above your midline. And because this is flipped, you're going to count down from the midline 2 units because that is the amplitude. And then with your pencil floating on the midline at the middle of the wave, which is at the 180 mark, normally you would go down to create that deep valley, but since we're flipped, you're going to stretch up the amplitude of 2 units. And then again, at the end, your pencil is on the midline, but you're not making a point on the midline. You're stretching down 2 units. You would connect those to make your graph. Okay. All right, let's try one more. Letter D. Okay, this is another degree problem. Okay. And for this problem, we're going to just real quick label our 5 critical values here. Okay, I noticed that this is a sine wave problem, so I'm going to keep that in mind when we graph. I'm going to answer that the midline's at -4. The amplitude on this one is a 1/2, and this sine wave is not flipped. So when I think about the sine wave, I'm going to expect it to keep this same shape, going up and then going down. Okay, so let's put the midline in place here. We said the midline is at -4. So I'm going to extend this, whoops, just a smidge here. Okay, so the midline is going to go right across there. Okay, now this is the sine wave. So instead of placing 2 points on the midline like we do with cosine, we're placing 3 points on the midline, and we're placing them in the other locations, beginning, middle, and end. Okay. Once again, imagine now if you were to have your pencil floating above the midline at the 1/4 mark, which is the 90-degree mark. Typically, the sine wave, that's when it goes up and makes the very top of that hill. And we said, look, we're not going to flip this one. So I am going to count up, but look how much I'm counting. Not very far at all. I'm just going up half of a unit. So I'm only going up to -3.5. And I probably need to label this down to -5 here. And then at the 3/4 mark, that'd be right here above the 270 or below the 270, I need to stretch down from the midline my amplitude, which is just half a unit. So now I'm stretching down to like -4.5. Okay, and then I connect those. Think of it like this. Your amplitude is either a vertical stretch or a vertical shrink. Okay, we never said those were negative when we identified those. And you can tell, it definitely feels like this sine wave has kind of been shrunken or smashed somewhat vertically. And that would be right in line with what we've discussed all year with that being a fraction. Okay, I hope that helps some of you that are confused on this. Have an awesome weekend, you guys. Get outside and enjoy the weather.